So let's go ahead and start topic 6, the atmosphere. Topic 6.1 will be an introduction to the atmosphere. What we've been doing so far in ESS is looking at how environmental conditions are affected in different parts of the world. One, of course, would be in the soil, what we call a lithosphere. Another would be in the oceans, the water, hydrosphere. And today we're going to start talking about how environmental conditions are affected in the air, the atmosphere. Most people think that the air is pretty much all oxygen. Of course, it's not. It's actually mostly nitrogen. Depending on what textbook you see, it's anywhere from 78 to 80%. Oxygen is usually about 19 or 20%. And the idea basically is that oxygen needs to be dissolved in a carrier, so it's a solution. It's homogeneous. We don't see the oxygen. But actually, most of what we're breathing is nitrogen. However, nitrogen is not soluble in blood, doesn't bind to hemoglobin. So we're really only interested in extracting the oxygen. By the way, just as a fun fact, pure oxygen is extremely combustible. So we would not want to be living in an atmosphere that was that high in oxygen. That's almost 99% of the gases, if not more than 98%. There are some other dissolved gases, water vapor, carbon dioxide, ozone. We'll talk about that later on. Some inert gases, of which argon is the highest. But pretty much we're thinking about the atmosphere as being nitrogen and oxygen with a little carbon dioxide and argon mixed up in there. So let's talk about the carbon dioxide, which is a very, very small percentage. It's only 0.4. Quite small. There are natural and artificial reasons why we have carbon dioxide. Volcanic activity, forest fires, of course, would create carbon dioxide. But industrialization, as we'll talk later on in unit number 7, has been a big cause of the increase in carbon dioxide. So even though it's a very small percentage of the atmosphere, it's changing very quickly. So let's go back and talk about the atmosphere. The atmosphere is actually quite thick. Can't remember exactly how much it is, about 300 miles, I think, something like that, which exerts pressure. Gases do have density and pressure. Obviously, it exerts 1 atmosphere of pressure on us. That's pretty easy to figure out. The atmosphere, however, is so big that we divide it into 4 different layers: troposphere, stratosphere, mesosphere, and thermosphere. Why are there 4 different layers? Different gases have different densities, so they will rise because of their physical factors to different levels here. And then it's very interesting. Different gases absorb different types of solar radiation. Some absorb UV radiation, some absorb heat radiation, infrared. There's gamma, cosmic radiation, radio waves, microwaves. Anyway, depending on which gases, because of their properties, absorb which type of radiation, they have different temperatures. And so it's kind of interesting. So it's opposite. The troposphere actually gets colder as you get higher. So if we climb up to the top of Mount Hood, it gets colder and colder. When you're up to the stratosphere, it starts to get warmer as you get higher and higher. When you get to the mesosphere, it gets colder and colder as you get higher and higher. And thermosphere, that's easy to remember, gets hotter as we go higher and higher. The interesting thing to remember, let's just talk about the troposphere, is that is therefore where all weather takes place. So when it's raining, it's taking place in the troposphere. The reason why planes like to get so high up here, or one of the reasons, is they like to get above the weather patterns. So when a commercial jet flies to the top of the troposphere, they're actually above the weather conditions. And for those of you who have been in jet planes, you can look down and you can actually see it raining down below you. The stratosphere up here is very interesting too. That's where the ozone layer is going to be, and we'll talk about that a little bit later on. So the greenhouse effect. The atmosphere acts as if it were a blanket sitting on top of the Earth. In other words, it keeps us a lot warmer than we should be. Can't remember exactly what it is, but it probably changes us about 100 degrees. So planets which don't have a lot of atmosphere, you can see the problem going on here. And how does it do that? Well, radiation comes in from the sun, and it comes in at high energy. We tend to refer to high energy radiation as short wave or high frequency radiation. When it hits the Earth, short wave radiation, it loses energy because the Earth is absorbing some of the energy. So the radiation that is reflected back has less energy, and therefore it is long wave. Why is this important? Because since the wavelength of radiation changes when it hits the Earth and when it's reflected, it changes which gases can permit it to go through it. So there may be a greenhouse gas which allows shortwave radiation to go through it, but when it gets reflected as a long wave, it traps it in there. Very clever. So that is the greenhouse gas effect. So the greenhouse effect then traps in infrared long wave radiation and keeps the planet warmer than it should be. Now, this explains why when we have increased gases by burning fossil fuels, we would have a warmer planet. Unbelievably, people forget we talk so much about carbon dioxide that the major greenhouse gas is just good old water vapor. Clouds actually do more than anything else to regulate the temperature on the planet. And mostly it's natural, although later on we'll talk about how water vapor has been changing because of climate change. But for now, let's think about water vapor as being cloud cover. There are essentially four groups of clouds, different if you look at different texts. Cumulus are the white puffy clouds we tend to see in the sky. Those are the ones that typically have rain. Stratus clouds are the ones we see at the lowest level down here. Nimbus clouds, also rain clouds, those are the ones who start to look dark and gray. And when you see those, you go, oh, they're coming in, here comes the rainstorm. And then cirrus clouds are the one way, way at the top, those long, whiffy kind of clouds. The albedo effect. Okay, the albedo effect, a very simple way to think about this is how radiation is reflected from the Earth. And it's very, very simple. The shinier the surface, the more energy is going to be reflected and not absorbed. Oceans, lakes, glaciers, any kind of ice would do a really good job of reflecting energy, and it would not get absorbed. So that is the albedo effect. We can think about it in two different ways. Negative feedback and positive feedback. Just to remind you, negative feedback means the effect counters the stimuli and we get back to the set point, whereas positive means we get further away from the set point. So let's look at a negative effect. When temperature goes up, we get more rain clouds. This increases the albedo effect, which causes the ground surface to cool again. So that's a good thing. Positive. As global warming melts ice, this decreases the albedo effect, less reflection, but this then causes more radiation to be absorbed, because you have less albedo, which causes even more ice to melt. And that concludes our introduction to the atmosphere.